Hello, my name is Dayton Matthews, and thank you for listening to my presentation on designing robotics in the medical field. So the first robot that I would like to take a look at are surgical robots. So these robots have quite a few benefits. They keep medical workers safe, which was especially important during the COVID-19 pandemic. As pointed out by Shi in their paper over designing medical robots, during the COVID-19 pandemic, many hospitals had to restrict to surgeries to only emergency surgeries because there was too high of a risk of patients getting sick from doctors or vice versa, which is dangerous. They're also, surgical robots are also more precise, which leads to less invasive surgeries, so they can perform smaller cuts, which leads to less bleeding and faster recovery times, which is good for patients. Robotic surgeries also have more cameras and sensors, which can lead to better vision for the doctor, or if a surgery is performed solely by a robot, then the robot can have a full view of the surgery, which can help in the event of anything unexpected that may occur. So now I'd like to look a bit about how we design these robots. Typically, engineers will use computer-aided design software or CAD software, such as this one right here. All of these designs were designed using SolidWorks, which is a pretty popular computer designing software. This type of software allows for many design iterations, and then we can compare the designs based off of how they meet what criteria we need. This software can run simulations that will allow for the engineer to test to make sure the parts will be strong enough to not break whenever they have to perform their actions. It'll make sure that the parts don't accidentally hit each other in ways that they're not supposed to, and you can test out different parts for one another to make sure that you have a motor that has enough torque to do what it needs to do. Next, I'd like to look at a specific part that was proposed by Patel that could be used for surgical robots. These are high-performance brush frameless motors. The benefit of these motors are that they, compared to conventional motors, have a permanent magnet, which allows for current to be run through the motor at varying speeds that can lead to very slow but high torque movement that gives the precision that's necessary for surgical robots. Next, I'd like to look at how we can compare certain designs by using a scoring system. So here we take our previous designs of robot and we judge them based off of how well they meet our criteria. Are they precise enough to perform surgeries? Are they cost effective? And are they easy to manufacture? Cost and manufacturing are really important for any robot because no one's going to buy your robot if it's too expensive, and thus we can't really help people. But how easy it is to use and how precise it is also important because it's at the end of the day a surgical robot and needs to be able to do what it needs to do. So using a scoring system like this, we can take a bunch of different ideas that we need our robot to do all of these and prioritize each one and figure out which design best fulfills all of the needs of the robot. Next, I'd like to look at a different type of robot, which is a delivery robot that I think could be implemented into the medical field as well. So first, let's look at some of the benefits of this robot. They, similarly to the surgical robots, can keep health workers safe because they can help reduce the amount of times that nurses or doctors have to visit patients for just normal day-to-day tasks of delivering medicine, delivering foods, or delivering linens. They no longer have to go to the room for that, which frees up time and saves money for the hospital by reducing the amount of repetitive tasks that health workers have to do so they can focus more time on different aspects of patient care, such as diagnosing or something along those lines. Also, in a study by Zhao, a robot was used in a hospital pharmacy and was able to accurately keep track of how many of the hospital's pharmacy's inventory. So the robot would take medicine and would dispense it to patients and then would keep a live track of all of the medicine in the hospital, which is important for keeping track of how much stock we have of all of our medicines. So the design of this robot would require quite a few sensors. So we could use cameras and ultrasonic sensors in order to avoid any obstacles. Ultrasonic sensors are quite important because they use sound waves to detect how far away an object is. So cameras take in a lot of visual data, but ultrasonic sensors can be combined with that to make sure that it's sure that there's an obstacle right in front of it and that it can't go that way. You could combine this with a Wi-Fi network of robots to have them communicate with each other and inform of any blocked hallways or anything like that throughout the hospital. There's another sensor that I think would be very beneficial in this type of robot, which is ultra-wideband sensors. These were done in an airport case study by Shen, where they used these types of robots in order to transport luggage throughout an international airport. These types of sensors have multiple routers that sends out signals to the robot, and the robot will take in the signals from the routers and can tell how far away it is from each router. Then using that, it can triangulate its position inside of the facility to tell exactly where it is within a hospital, and kind of like a GPS, it can tell where it is and how it can get to where it needs to be. In conclusion, there are many ways that robots can be used in the medical field that can be beneficial to everyone, and how we design these robots is very important. Thank you for listening to my presentation. Goodbye.